In this video, I'm going to go through how to find the type of quadrilateral using all the skills that we've done before. So you get given a problem like this, where you've got 4 vertices, and they form the vertices of some application shape, and we want to find out what shape that is. Now you can use these skills for multiple things, but in this video we're just going to focus on finding the type of quadrilateral, because there are infinite shapes. Okay, so we start off with finding the distance and gradient of each of our lines. So our first line is AB, where A is 1 minus 4 and B is 0 minus 2. We always label our coordinates so that we can then apply them in these formulas. We find the distance first. The distance of AB equals the square root of x1 minus x2, so that's 1 minus 0, squared, plus y1 minus y2, so minus 4 minus minus 2 squared, all under the square root. Then we start simplifying. 1 minus 0 is 1, minus 4 minus minus 2 is minus 2, 1 squared is 1, minus 2 squared is 4, 1 plus 4 makes 5, square root of 5 is 2.24. Then we've got to find the gradient. y2 minus y1, so that's minus 2 minus negative 4 over x2 minus x1. So that gives us 2 over negative 1, which gives us negative 2. So there's a gradient negative 2 there. Then we've got to do the rest of our lines. So BC, B equals 0 minus 2, C equals 1 minus 1. That's our x1, y1, and our x2, y2. We've got to get the distance. So square root of x1 minus x2, y1 plus y1 minus y2, which gives us minus 1 squared and minus 1 squared as well, which gives us, again, square root of 1 plus 1, which after that gives us square root of 2, which is 1.41. Then we've got to find the gradient of BC, which is y2 minus y1 divided by x2 minus x1, which gives us 1 over 1, which equals 1. Then we've got our next line, so CD, C equaling 1 minus 1, D equaling 2 minus 2, x1, y1, x2, y2, where the distance of CD equals the square root of x1 minus x2 squared plus y1 minus y2 squared, which equals 2. Minus 1 squared plus 1 squared which equals 1 plus 1, which equals 2, and the square root of 2 is the same as before, which is 1.41. Then we've got to do the gradient of CD, which is y2 minus y1 over x2 minus x1, which equals minus 1 over 1, which equals minus 1. And then we've got our last one, which I don't have enough room for on this page, so we'll do a new page. We've got AD, where A equals 1, negative 4, and D equals 2, negative 2, x1, y1, x2, y2. So your distance equals square root of 1 minus 2 squared plus minus 4 minus negative 2 squared, which equals to negative 1 squared plus negative 2 squared, which equals to 1 plus 4 equals the square root of 5, which equals the same as before because we had square root of 5 there, so it's 2.24. We've got our gradient equaling y2 minus y1 over x2 minus x1, which equals 2 over 1, which is a gradient of 2. Now that we've got all those, we need to prove which lines are perpendicular to each other and which angles are the same and which are parallel as well. So if we look at our gradients, we have a gradient of negative 2, a gradient of 1, a gradient of negative 1, and a gradient of 2. So, no sides of A, B, C, D are parallel because all gradients are different. But with our distances, we can see that AB has the same distance as AD and BC has the same distance as CD. So distance of AB is equal to the distance of AD because they both equal 2.24. And the distance of BC is equal to the distance of CD because they both equal 1.41. The last thing we need to work out is if our angles are perpendicular or are right angles, or if our angles are the same as each other. So we've got to multiply all of our gradients. So the gradient of AB times the gradient of BC, let's find that out because we're trying to find out if this is a right angle. So the gradient of AB is minus 2 and the gradient of BC is 1. Minus 2 times 1, which equals minus 2. So that is not a right angle. Let's do the next corner. Let's do BC times CD, and that is BC of 1 and CD of -1, which equals -1. That means that BC is perpendicular to CD. Okay, so we have a right angle in here. Let's look at our next one. Gradient of CD times the gradient of AD to find out if this here is a right angle. So the gradient of CD is -1 and the gradient of AD is 2. And that is the same as the gradient of AB times the gradient of BC, because you can see they both ended up as -2. So that we know that these two angles here are the same. Our last one is the gradient of AD times the gradient of AB to find out if that is a right angle. Now, it sure doesn't look like it, but let's find out. So we've got -2 times 2. Let's do that the other way around, because we've got AD first, which equals -4. So that's definitely not a right angle. So now we use that to prove what kind of quadrilateral we have. Now our quadrilaterals are these ones here. We have the square, which will need 4 equal length sides, 2 sets of parallel sides and 4 right angles. We've got the rectangle, which has its own set of properties, the rhombus, which also has its own set of properties, the parallelogram, the trapezium, and then we've got the kite. Now the kite has 2 sets of equal length sides and 1 pair of opposite angles which are equal. So that means that the shape that we have is the kite, because our 2 ends of our shape are equal and of equal length, and our opposite angles are equal. Okay, so the shape of the rose garden is a kite because it has 2 sets of equal length sides and what was the other thing that we needed to say? 1 pair of opposite angles which are equal. Okay. Now, the 2 sets of equal length sides comes from this, because AB and AD are the same length and BC and CD are the same length. 1 pair of opposite angles which are equal comes from this, because we found that AB and BC made an angle that is the same as AD and AC, which is this one here. Thank you for watching and good luck with your tasks. Remember to memorize each of the sets of properties for each of these quadrilaterals, and if it doesn't fit any of these, it's an irregular quadrilateral. Good luck for next time.